Now, the whole point of graphs is to be able to illustrate how two variables relate to each other, how two quantities relate to each other. A graph is a nice way to see a picture of how that happens. It's a more of an intuitive approach to analyzing how one variable affects another, uh, rather than just staring at an equation. So that's the point of the graphs. And each line now that we're going to talk about has its own characteristics. One of those characteristics is what we would refer to as the slope of the line. Okay, so for example, if I had a graph out here, let's see, here's a line. It's rather steep, moving from left to right. In fact, it's much steeper than this one. Doesn't go up as fast or as high as fast. And in fact, this a line like this actually is moving down to the right. So what these show are different slopes. Lines that go up to the right, like this one up to the right, have what are called positive slope. Okay, lines that go down to the right, like this one here, down to right, they have negative slope. Okay, lines that are just kind of like right in the middle that don't really go up or down, horizontal lines, zero slope. And there's one more kind of line that we talked about, and that's a vertical line. If you see something like this, straight up and down, vertical line, has undefined slope. We have to remember that undefined slope. Okay, undefined slope. Okay, now next step is to quantify this number, or quantify this characteristic with a number, because we have to have numbers to work with there. So what we need is a definition of what slope is mathematically, and that definition we start with m, special symbol for slope, and it will be the change in the y coordinates. Whoops, let me go back on that. It's the change in y divided by the change in x. That's a definition. Now, so in other words, if you have two ordered pairs out on a curve, here's one and here's another, it's sort of random. This ordered pair might have coordinates, let's see, x1 comma y1. And this point over here might be x2 comma y2. Here the subscripts just indicate which ordered pair the x and y values belong to. These two belong together at this point here at 2.2, and these two go together. So in our definition over here, we just have to take the difference between those. That will give us the change. If you subtract find the difference between the y coordinates, that's the change. So this is our definition. This is the one that we'll be working with when we calculate slopes for different lines. Okay, we're back again here, and we're going to do another example here. Let's find some slope. Let's say we're giving it. We have an equation x plus 2y equals 6. Now, if we want to find the slope, okay, find the slope of this line. Now, you could graph it and try to find this, but we really don't need the graph to calculate the slope. We just need two ordered pairs. You might want to graph it once you have the ordered pairs, but we just need the ordered pairs. So you can organize your ordered pairs like this. And let's just pick some numbers. I'm going to pick x equals 0. That gives me 2y is 6, so I know that y is a 3. So there's one ordered pair. We need another one. Let's say, again, let's go with the zeros. Let's pick y equal to 0 this time, since we can. And that gives us x is a 6. So there are the two ordered pairs. So that's step 1. We have the ordered pairs to work with. Now, step 2, let's use our slope formula. M equals y2 minus y1 over x2 minus x1. Okay, and you just decide how you want to name these points. This could be point 1. This could be point 2. So if we're going to do that, then over here we would have point 2, the y coordinate is a 0. Point 1, the y coordinate is a 3. Point 2, the x coordinate is a 6. And point 1, the x coordinate is a 0. So we form this, we'll have negative 3 over 6. And that can be reduced to negative 1/2. So that's how we calculate the slope. Notice the slope can be negative and it can be fractional. Okay, it's fractional. Now let's look at the lines. We weren't here to graph this line, but let's go ahead since we have a couple ordered pairs anyway. So let's put that 0, 3 on here. Here's 0, 1, 2, 3. And 6, 0. Well, that's off the grid, but I'll just kind of fake it over here. Put it right there. Whoops, it doesn't let me do that. There, okay, it's right there. And if you connect these points, in fact, this one, maybe I'll try to use that line tool. Run through here like that. There it is. Okay, good enough. And what you notice about this is, okay, the slope is negative 1/2. The line is heading downward as it should with a negative slope. And if you just pick two random points here, let's say point here and point here, what you notice about them is that this distance along here is a 1, and this distance is a 2. And since it's going down, we see that for every change, and every 2 units that x changes, y will drop down by 1. Or you could say every 1 unit that x changes, y will come down by 1/2. That's where the slope comes in. This gives us our unit change. If x changes by 1, then y will change by negative 1/2. Okay, it'll drop by a negative 1/2. So we call that a slope triangle. You can put that into your grids if you want and onto your lines. And that's how slope works.